And as well as being interested in science, he was a human biology teacher and a very keen naturalist. And as I grew up, he was always pointing out things to me in nature, birds, etc. And it turns out that I've had a vocation in nature conservation. And I was instrumental in helping to set up a charity and accepted the MBE in 2007 on behalf of my colleagues at the charity that I helped to set up. But I should say from the outset that I'm not a climate scientist and I probably won't have all the answers to your questions, but I can certainly tell you where I would go to look for the answer. Okay, so let's go. First things first. Habitable planets are really, really hard to find. So in the universe, we've identified about 1 billion planets. And out of those, we only know of 2 with an atmosphere and water, or at least only 2 that are solid. Water is actually quite a common element amongst planets, but a lot of the ones that have water are not solid or don't have an atmosphere. So we only know of 2. One of them is called Earth and the other is called K2-18b. And just in case you were thinking that if life here ever became unmanageable, you or your descendants could fly off somewhere else to live, even if you could go at the speed of light, it would take you 111 years to get to K2-18b. And by the time you got there, if you survive that long, you probably find it's not habitable anyway. So we really are totally dependent on one little blue planet, which we call Earth. In order to carry on living successfully on Earth, what do we need? What is it that we really need? Well, Earth is only habitable because it has a balanced climate system. And scientists have divided this climate system into 5 component parts, and they give them fancy names. So the first part is the cryosphere, which is basically a fancy name for ice. So it's all of the ice and the compacted snow, the frozen ground, permafrost, it's mountain glaciers, etc., polar ice caps, sea ice. And you might think, well, why is our climate system dependent on that? And it's really for 2 reasons mainly. One is because there's so much cold stuff in our climate system that it has a direct kind of cooling effect. And also there's so much white surface area with all these compacted snow and ice at the poles that a lot of the incoming heat from the sun is reflected back out into space, which I'll come back to in a little while. And then the other component parts of the climate system, well, we've got the geosphere, the hydrosphere, and the ecosphere, which is basically our land, particularly the fertile soils where plants can grow, the way that water moves around the planet, so not only the ocean currents distributing nutrients, but also the way the oceans evaporate, water vapor goes up, forms clouds, falls as rain, obviously is essential for soil fertility, and put these things together, the fertility and the nutrients, and we have our ecosystems. And it was life on Earth, it was the ecosystems that created our atmosphere, which is the 5th essential part of our climate system. So we would only have to lose one of those and Earth would become uninhabitable. It might take a while, but it would certainly happen. But hang on a minute, what's the fuss about? Because the Arctic and the Antarctic are still frozen and we still have fertile soils and it still rains. We still have ecosystems, we still have wildlife, we still have fish in the sea, and we can still breathe. So you might be thinking, well, what's the big deal? Well, if you start to look into any one of these in detail, you soon realize that things are changing. For example, ice is disappearing from planet Earth, and compared to previous times when it disappeared, it's disappearing incredibly fast, and the rate of loss is accelerating. Crops do still grow, thank goodness, but globally, regionally, and locally, crop failures are on the increase. And this is something that we have been impacted by quite recently. You might remember in the news the lack of, what was it, tomatoes and cucumbers because of extreme weather in North Africa. There's plenty of examples around the world. It still rains, but globally droughts are very much on the increase. There are parts of the world that have been in severe drought for 3, 4, 5 years that didn't used to be. And we're seeing 4 to 6 week droughts every year here in the UK now. We still have wildlife, thank goodness, but wildlife globally is very much still in decline. And that decline, like the loss of ice, is accelerating. It's a bit hard for us to perceive that living here in the UK because, you know, we had blue tits on our bird table last year and we've got them again this year. And it seems that wildlife is fairly stable to us because we lost our large spectacular species thousands of years ago here in the UK. But globally, it's still something that's very much happening today. There are still fish in the sea, but globally, virtually all fish stocks are either fully exploited or crashed. We can still breathe, but we're the lucky ones. Air pollution is already killing over 8 million people a year. Why are these things happening? Well, depending on which row we're looking at, there could be more than one reason. But first of all, we're going to look at the climate crisis. So this is the biggest part of the presentation. To understand the climate crisis, you need to know something about carbon. Carbon is one of the building blocks of life. 18% of your body and my body is carbon. About 50% of a typical tree is carbon. Now, we've had complex life forms on Earth, which just means plants and animals, on Earth for about 540 million years. And during those millions of years, trillions and trillions of tons of living things have died and eventually become fossilized in the ground. And when living things, plants and animals, turn into fossils, they still contain the carbon that was in their bodies when they were alive. So they could be called carbon-rich fossils. But these days, we tend not to call them carbon-rich fossils. We call them fossil fuels because we pump them up or we dig them up and we burn them. And when we burn these fossilized remains of living things, we release the carbon into the atmosphere during the combustion. And this enhances something called the greenhouse effect. And when we release the carbon, of course, we're releasing it principally as carbon dioxide, also referred to as atmospheric carbon, CO2, or sometimes simply carbon. So it enhances the greenhouse effect, this additional carbon dioxide. So what's all that about? Well, the greenhouse effect is really quite simple to understand. We're very, very lucky on Earth that we have an atmosphere and it has this greenhouse effect. The way it works is that heat energy, solar radiation, comes in from the sun, see in the diagram there, comes down through the atmosphere, warms up the planet, the surface of the planet, and some of that heat is re-radiated, especially by the white parts, as I mentioned earlier, and some of that re-radiated heat is trapped by the greenhouse gases. So this is the carbon dioxide I mentioned already, but also nitrous oxide and methane, which is natural gas, and water vapor also is a very important greenhouse gas. And when I first heard about this, I thought, that doesn't really make a lot of sense, because if the heat energy can come in through the atmosphere, how come it can't go straight back out again? And the reason is because when it comes in, it's a relatively short wavelength of radiation, but the re-radiated heat is a longer wavelength, so it interacts differently with the carbon molecules in the atmosphere. Now, by burning fossil fuels, we've basically increased the amount of greenhouse gases, not just carbon dioxide, but the others as well. And so we're trapping more of the heat energy coming in from the sun, less of it is escaping back out into space. And so the climate system and the surface of Earth has warmed up. So, for example, back in 1880, when accurate temperature measurements began, the average surface temperature of Earth was 13.7 degrees centigrade. And in 2020, it was 14.9. So it's gone up in that time period by about 1.2, or a lot of scientists are saying 1.1 degrees, something of that order. Okay, so the world's a little bit warmer. What does that actually mean? Well, it turns out that the climate system is very, very finely balanced. You only have to turn up the heat a little bit before really, really dramatic things start to happen. And one of those is you get more storms, for reasons that I will explain as we go on. Because you get more storms, you get more rainfall-related flooding. In a hotter climate system, you get more droughts and you get more heat waves, and therefore you get more wildfires. And that results in the release of more carbon dioxide through the combustion. And a lot of these things result in less food being produced, which is obviously important. There's something else quite separate going on as well, which is called ocean acidification. And that's not strictly to do with the warming, but it's to do with the carbon we've added to the atmosphere. It turns out the oceans have absorbed about 31% of the carbon dioxide we've added to the atmosphere. And in the seawater, it becomes a very, very weak solution of something called carbonic acid, unsurprisingly. Now, that might seem a bit remote and a bit obscure and really nothing to do with you and me, but it is important if you're a shellfish, because shell is calcium carbonate. Shell is an alkaline substance. And if you're a little shellfish in the ocean, perhaps you're a little microscopic zooplankton, or you might be something big like a crab. If you're trying to grow your shell, the last thing you need is for the water to be more acidic. And there's already good data to show that growing shells in some species is taking longer or is less successful. So the world's a bit warmer, but hang on a minute. We've had some incredibly cold weather in recent years. How can you explain very, very cold weather on a planet that's supposed to be getting warmer? To understand that, I need to introduce you to something called the jet stream. Now, if you watch the weather forecast after the main news on the BBC, you've probably noticed that just in the last year or so, they've started talking about the jet stream. And the reason is because it has such an influence now on our weather. The Met Office forecasts, which you can see on their YouTube channel, have been talking about the jet stream for years. So what is the jet stream? Well, basically, it's a narrow band of really, really strong wind that blows around in the atmosphere, up in the sky, at about the same altitude that you would fly in a jet aircraft, hence the name jet stream. So at our latitude, it's about, say, 36,000 feet. And it blows at up to about 250 miles an hour. And it's driven, this wind, by the temperature difference between the Arctic and the tropics to the south. And it has the effect, this ribbon of very, very powerful wind at high altitude, it has the effect of separating cold polar air, Arctic air, from warmer tropical air. So on the national weather forecast, on the maps now, they're using yellow for the tropical air and blue for the polar air. You can see on the illustration here, it's pale where it's the polar air. And it not only separates it, but it can separate it right down to ground level. Pretty amazing. Now, when we say that the planet has warmed by an average of 1.1 or 1.2 degrees, that's the average surface temperature change, it hasn't warmed evenly. The Arctic has warmed more than 3 times as much as the tropics, which has reduced the temperature difference that's giving the jet stream its impetus. And as a result, the jet stream has become weaker. It very often doesn't blow at anything like 250 miles an hour. Whole sections of it can become very, very weak. And sometimes it fragments, as you'll see on the Met Office forecasts. If you go and look at their deep dive or their 10-day trend forecasts, you'll see that. In the illustration here, you can see how the jet stream is meandering now a lot to the north and the south. And as well as the wind blowing from the west to the east, those curves in the meandering jet stream, those curves actually move from the west to the east. But sometimes they stagnate, they stop moving. You can see in this illustration, the jet stream is shown by this curving line of brown arrows, and there's this overall motion from the west to the east. But if that overall motion stops, which it has done very recently, then if the UK happens to be covered in cold polar air when it stops, stagnates, then we can have a really long-lasting, very, very cold weather event. And you might remember in 2018, for the first time, we called it the Beast from the East. In fact, spring 2013 was even colder. That was the coldest spring since 1963. And these extremely long-lasting, extremely cold weather events are a result of this stagnation in the jet stream. Conversely, what can happen is the overall motion from west to east can stop when the UK is covered in warm tropical air and warm air is being pulled up from Africa or perhaps across Spain and Portugal. And that's what happened this summer when we had our heat wave. In fact, we've had two heat waves this year. The first one was about 5 weeks long, the second one only about a week long. Last year, of course, we had a 6-week heat wave, which broke all the temperature records across the UK and many of the ones across Europe. And those extreme heat wave events are caused again by this weakening of the jet stream and this stagnation of the west to east movement. So that kind of explains the cold weather we can get on a planet that's getting warmer. But what about the floods? We've had some extreme floods. I mean, I'm not just talking about the ones we're having now and the ones we've had in the last few days, but if you go back a few years, we had an extreme event. You might remember Storm Dennis in February 2020 was the worst flooding in recent years. We haven't had one quite that bad, although we've had some very bad ones. In February 2020, Storm Dennis came only 6 days after Storm Ciara, so the ground was already saturated, couldn't absorb any more water, and the flooding was absolutely tremendous. I don't know if it was where you are in Wiltshire, but it certainly was. I have a relative in the Severn Valley, and it was bad there, up through the Welsh borders, through Cumbria, parts of the east of England, extremely bad flooding. So what's going on with that then? Well, it turns out that the oceans of the Earth have not only absorbed 31% of the carbon that we've added to the atmosphere, they've also absorbed 91% of the heat energy that we've added to the whole climate system through burning fossil fuels. That is actually incredible because the oceans cover about 70% of the surface of the planet. So that is one hell of a lot of water. And if I said to one of you, please would you go out and warm up all the oceans in the world? You'd say to me, no, that is such a big task. That is absolutely impossible. Well, that's what we've managed to do through burning fossil fuels. We've warmed up all the oceans of the world, and not just on the surface as well. Measurable changes even deeper in the oceans. So what do we know about warm water? We know that warmer water evaporates more. It evaporates more quickly. So you get more water vapor. And warmer air, which we have on average, is physically capable of holding more water vapor. So the oceans are evaporating more. There's more invisible water vapor in the air, and more water vapor means more latent heat energy is released. Okay, now you probably haven't heard of latent heat energy. So I'm just going to explain to you very quickly, very simply what that means. Okay, imagine you're looking at a surface of the ocean. Okay, and imagine that we're applying heat energy. Okay, so the water is getting warmer, and at the surface, as it warms up, there comes a point in the warming where it actually stops warming up. And what it does is it changes into water vapor. So the liquid changes into a gas without any change in temperature. The energy that was warming up the water, the energy is going into now changing it from a liquid to a gas. And then you keep applying warmth to the water vapor, the invisible water. And of course, warm air rises. So that warm water vapor, that warm air goes up in the sky. And the higher you get, the colder it gets. So eventually it gets so cold that it condensates back into visible water. And that's what we call cloud base. The bottoms of clouds look quite flat because that is the altitude at which the water turns back into being visible water, which we call clouds. And when it turns back from a gas into a liquid at cloud base, it releases the heat energy that it took to turn it from a liquid to a gas. So that is how water vapor transports heat energy from the surface of the ocean to the base of the clouds, where it releases its heat energy and can cause it to continue to rise. And that is how a lovely little fluffy white cumulus cloud can turn into a ginormous cumulonimbus storm cloud that will give you torrential downpours and hailstones and thunder and lightning, etc. So that's how we get more extreme rainfall and therefore we get more floods. It's because of the warming. Okay, so we've covered quite a lot of ground already, and we're going to have a quick recap. Okay, so we've been burning loads and loads of fossil fuels since the start of the Industrial Revolution. So loads of carbon dioxide has gone up into the atmosphere, which has warmed the planet by about 1.2 degrees C, but the Arctic has warmed more than 3 times as much, which has changed the jet stream, which makes extreme weather more likely. And sometimes the weather we get is going to last for longer because of the stagnation. And the sea is warmer, so we're likely to get more rain, more storms, and polar ice is melting, warm water expands, so the sea is rising. We'll come back to that in a moment, but hopefully you're with me so far. Fantastic. But probably one of you is thinking, hang on a minute. We're talking an awful lot about carbon dioxide, and we're talking about it as if it's something really bad. But actually, carbon dioxide is really good. It's natural. It's brilliant for plants. If you have a plant and you give it more carbon dioxide, it'll grow better as long as it's got everything else it needs. So what's the big deal? And anyway, the amount of carbon dioxide in the atmosphere goes up and down like a yo-yo. So what's the big deal? Well, here we are only looking at the last 450,000 years. Okay, that's not very long. We've had complex life forms on Earth for 540 million years. So that's a much, much longer time. Here, we're just looking at the last 450,000 years. Look at the red line across the middle. That is average global temperature. And you can see that it's gone up and down like a yo-yo. And you can see that with it, the CO2 concentration, the green line, atmospheric CO2, has gone up and down as well. And what's happening here is that when the red line is low, it's very, very cold. That's an ice age. So you can see we've had 1, 2, 3, 4 ice ages in the last 450,000 years. When it's very, very cold, there's less production of CO2 going on from life on Earth. And so the amount of CO2 goes down. And also it's so cold that lots and lots of the fresh water on Earth is being locked up as ice. And so the sea level goes down. You see the blue line at the bottom is the sea level. So when the temperature is low, the CO2 is low, and the sea level is low. Okay. Now, if you look at the red line again, look at global temperature, and you look at the right-hand end, you can see where it says Holocene. I wonder if my cursor will work. There it is. Look, this area here, that is the geological time period that we've been living in. Okay. And it's in that period when all of our human civilizations have happened. So it was about 6,000 years ago that we had our first human civilization. And it happened somewhere called Mesopotamia, which we now call Syria. And it was the first time that thousands of people had lived together. Now, you can only have thousands of people living together if you've got farming. So this was the very beginning of farming, about 6,000 years ago. And it was facilitated at the time by this period of relative temperature stability. The world wasn't incredibly hot and it wasn't in an ice age. So it was conducive to the production of food. Okay, so that little period. Now, of course, humans have been around for longer than that. And modern man first appeared, see down the bottom there, about 300 to 200,000 years ago is when modern man and woman, Homo sapiens, first appeared. And we were definitely modern by about 100,000 years ago. But all through the last 300,000 years, until we got to 6,000 years ago, there was hardly anybody, hardly any of us on Earth. And then we had our first civilization. Okay, so now if you take your eyes off the red line and look at the green line, you see up here, right-hand end, in virtually no time at all, through burning fossil fuels, we've increased the concentration of carbon dioxide in the atmosphere from a normal maximum of about 280 parts per million to 420 parts per million and rising. And because low atmospheric CO2, global temperature, and sea level tend to go up and down together, because the CO2 has shot up, it kind of makes you think it's quite likely that the temperature is going to go up and the sea level is going to go up. Well, we know the temperature is already going up, and sea level rise is actually one of the easiest things to predict amongst the resulting changes from climate change. The reason sea level rise is relatively easy to predict is well, more than one reason. Firstly, as you warm up water, physicists can tell you exactly how much it's going to expand, how much the level is going to come up as you warm it up. Also, we've got a good handle on the amount of fresh water that's being added to the oceans by the melting of land ice. But also, it's fairly easy to predict sea level rise because of the delay between burning the fossil fuels and the sea level going up. So the sea level rise we're going to see tomorrow is not because of the fossil fuels we burned yesterday. There's a delay of somewhere between about 30 to 50 years. So the sea level rise we see today is from the fossil fuels that we burned up to roughly 1990. The fossil fuels we've burned since 1990, which is actually about half of all the fossil fuels that we have burned, they haven't really come into play yet. Of course, in these projections of sea level rise, there is an element of future fossil fuel burning, but the projections used to produce these maps I'm showing you are not a particularly high level of future fossil fuel burning. It's a kind of medium amount of fossil fuel burning. So on the right-hand side of the picture here, you can see Teignmouth. This is where I grew up. This is the 2050 flood map. So within 27 years, half of Teignmouth town centre, my hometown, is going to be flooded by the sea every year. Half of Newton Abbot, the nearest big town, is going to be flooded by the sea every year. Now, of course, you're not here. You're up in Wiltshire, probably not a million miles from Somerset. This is not a good time to move to West Somerset because the sea is going to invade Somerset. It's going to go right past Glastonbury. It's going to go south as far as Martock. Look on the A303, which is the road to Wiltshire from where I am down in Devon. It's going to be both sides of the M5 motorway connecting Exeter and Bristol. It's going to be both sides of the railway line, and it's going to surround Hinkley Point Nuclear Power Station, which is over here. It's also not a good time to move to North Cambridgeshire, Lincolnshire, East Yorkshire, or the Humber Basin. And so this won't be unusual, because this is the current normal maximum annual sea level plus the sea level rise. So this won't be exceptional. This will be the normal yearly maximum sea level. So these maps are actually really scary, especially if you happen to live here, bearing in mind also that about 10% of the food that's produced in England comes from this area. But I should point out there are two things that these flood maps don't take any account of. They don't take any account of sea defences, sea walls. So in some places, the flooding won't be so bad, which is brilliant. They also don't take any account of storm surges in sea level, which in this instance would be when the wind blows from the northeast and piles up the seawater against the coast. So there will be times when the flooding is much, much worse than is shown here on the map. So that's pretty serious. And of course, it's not just flooding we're interested in. We want to know what's likely to happen, particularly within the lifetime of today's children. So let's look at the next 77 years. For some reason, this century up to 2100 is normally about the maximum extent to which we look into the future. Very few scientists seem to be looking beyond 2100. So let's have a look. Of course, the key thing we want to know is what's going to happen to global average temperature. And we expect climate scientists to be able to tell us. But in order to run their computer models to predict future temperature increase or sea level rise or whatever, in order to run their computer models, they need to know how much fossil fuel we're going to burn in the future. But nobody knows that. So they create what's called representative concentration pathways. So that's the concentration of atmospheric CO2. And these are representative pathways of, well, the red one is a very, very high amount of future fossil fuel burning. So it's a high amount of future emissions. And the grey one is lower. The yellow one and the blue one obviously are lower again. So let's say, just for argument's sake, that into the future, the next 77 years, we continue burning huge amounts of fossil fuels and create huge amounts of carbon emissions. If we follow that red line with our emissions, within 77 years, or at 77 years, the average surface temperature increase will be between 3.2 and 5.4 degrees centigrade. Well, we better hope that we don't do that, because that would be enough to wipe out most life on Earth. We know that from previous mass extinction events. So that's really not a good idea. Well, let's say we don't do that. Let's say that we carry on burning fossil fuels and increasing our emissions with a much, much smaller amount, following this grey pathway, which would take us to an average surface temperature increase of somewhere over 2 degrees, maybe up to 3.7 degrees. Well, we better hope that we don't do that either, because at an average surface increase of anything over 2 degrees, we would probably see the collapse of civilization for several reasons, in fact, more than several reasons, but the main one being the effect it would have on food supplies. And it would very likely cause what's called multi-breadbasket failure. So multi-breadbasket failure is when the major food growing areas of the world, there's about 5 of them, all have a bad year in the same year. And so they export a lot less food. And the effect of that would be that countries like ours, who only produce 40% of the food we grow, would be incredibly vulnerable to food shortage. Food prices would go through the roof, and globally, millions of people would be starving, and millions of people would be migrating, trying to find somewhere where they could at least find some food. The combination of uncontrolled inflation, uncontrolled migration, and mass mortality would cause lots of things. It would cause economic crash. It would cause bread riots, martial law, the breakdown of law and order. Um, Crops and animals would disappear from the countryside. It would be a future that really doesn't bear thinking about. So that's not a good idea. It may be that we actually start to reduce our emissions substantially after the middle of the century and end up with a temperature increase somewhere over 1.7. Of course, that range could still be over 2 degrees, which would be bad. But let's say it was 1.7, then we'd see more of the kind of impacts that we're already seeing. And representatives of all the world's governments and scientists have agreed that what we need to do is to follow this blue line. We need to very, very, very rapidly reduce our emissions from burning fossil fuels. So by the time we get to the latter part of this century, we're below carbon neutral. We're actually taking carbon out of the atmosphere instead of adding more. That's where we need to be. But at the moment, frankly, that looks completely unattainable. But great effort has been made to try and address this. And you might have heard of something called the Paris Agreement, which was struck in 2015 at a COP meeting, a conference of parties arranged by the United Nations through the IPCC, the Intergovernmental Panel on Climate Change. So here you've got the graph again, you've got the red line leading to most life wiped out and the blue line leading to where we need to be. And between the two, you can see that little black and white dotted line. That is what would happen to future carbon emissions if all of the countries in the Paris Agreement did what they said they were going to do. In other words, the pledges they made are too weak. They're good, but they're not enough to keep the temperature increase to below 2 degrees average, which is the upper limit of the target set in the Paris Agreement. But of course, since then, we've had COP26. Do you remember that meeting in Glasgow, which was just before the Christmas before last? And last year we had COP27, that meeting in Egypt. So these are, again, these international meetings where everybody gets together and decides to, do what they can to reduce emissions. Well, COP27 was pretty much a failure. There were no additional emissions reductions agreed in COP27, but there were some agreed in COP26. So what's that left us heading for? The pledges made in Glasgow at COP26 have left us heading for an average temperature increase, surface temperature increase of between 1.8 and 3.3, the mean of which is 2.5. So that is still very much in the danger zone, enough to cause the collapse of civilization. If you look not at the pledges, but at the policies of the governments that made the pledges, it's actually left us heading for more like 2.8, which is definitely way, way up there in the danger zone. How likely is it that these meetings and all these pledges will make a difference? Well, here's a graph showing the accelerating increase in carbon emissions from burning fossil fuels since 1850. And to this graph, I've added that grey flag that you can see that says COP1 to COP25. That is the time period when there were 25 of these meetings to try and agree emissions reductions. And you can see that the first 25 meetings made absolutely no difference. At least they didn't stop the accelerating increase in fossil fuel burning and emissions. So if 25 meetings have failed, it kind of makes you feel it's quite unlikely that another couple of meetings are going to make much difference. In their latest report, the IPCC, well, they've changed the color of the line. That blue line is now a green dotted line. And they're still saying we need to rapidly get off fossil fuels. We need to reduce our emissions from fossil fuel burning and get below carbon neutral before 2060. In 2018, they said to do this, we must reduce our emissions by almost half by 2030 and reach zero by 2050. Well, we haven't. We should be well on track to that now if we're going to reduce them by half by 2030. And in fact, they're not reducing, they're still going up. So the language changed. In the next report in 2022, the IPCC are now saying, if we want to limit warming to 1.5, which is the lower target in the Paris Agreement, we have to do it now. It's now or never. Well, that was last year. We still didn't do it. So now the language has changed again, and they're saying, we are now likely or very likely to exceed the 1.5 degree target in the near term. And having investigated that, what they seem to mean is by 2030, in the next 7 years. Outside of the IPCC, there's another group of scientists who have been looking at this and taken quite a different approach. And this graph, rather than showing you emissions or temperature, rather than showing emissions, is showing you temperature. And this study is actually principally looked at the energy imbalance. So I told you earlier about the amount of heat energy coming in to planet Earth from the sun and the amount of heat energy leaving. And through trapping more of that heat energy, we've created an imbalance. And this study is looking primarily at that imbalance. And it's looking into the paleoclimate record, so looking into the distant past, as far back as 66 million years, to look at how the Earth responded to previous occasions when there was an energy imbalance. And this has come up with some different results. They've identified, for example, that up to 2015, the rate of warming was 0.18 degrees for every 10 years. But after 2015, it's virtually doubled. It's over 0.27 degrees per 10 years. So hence the yellow area you see on the graph there saying accelerated warming. And you can see that by 2050, that takes us over 2 degrees in this graph. And they made the statement, there's this group of scientists outside the IPCC, that global warming, they reckon, will reach the 1.5 by the end of the 2020s and 2 degrees by 2050. And other organizations outside the IPCC have looked at this as well. The World Meteorological Association, for example, published a report this year in May and said that there is a 66% likelihood that we will exceed 1.5 by 2027. So what's that? 4 years' time. The United Nations emissions report from last year said that by the end of the century, we're likely to hit 3.2, even if all the commitments made are met. Blimey, even if the commitments are met, 3.2. Our own UK climate change risk assessment published last year said that we should prepare for warming of up to 4 degrees, as if that was something we could survive. And the Secretary General of the United Nations has made this statement: we are on a highway to climate hell with our foot still on the accelerator, because we've basically been failing to heed the warnings and take sufficient action. So if we carry on the way we are, then life as we know it will be over. It's just a matter of time. So, if you didn't already understand, maybe now you understand why the protesters are saying things like, tell the truth. If you think about it, the information that I'm giving you shouldn't be coming from me. You should know all this already, because a responsible government would have told you. All the governments of the world should have told all the people of the world, all the institutions, all the industries. Everybody should know about the situation we're in. And if we did, maybe we'd be more inclined to do something about it. Maybe you understand why the protesters are saying things like, act now. In fact, we don't really need to have acted now. We should have started back in 1988 when the IPCC was formed, and in the early 90s when the problem was first flagged up to governments. The Secretary General has made this statement about the protesters. So this is the top diplomat of the world saying that the dangerous radicals are not the protesters. The dangerous radicals are the governments increasing production of fossil fuels. And guess what? The UK government is one of them. Sorting this out is an absolutely massive challenge because of the sheer amount of fossil fuels that provide the world's energy. So this graph shows you the source of all of the world's energy. And you can see the grey, the blue, and the pink areas there. Coal, oil, and gas make up nearly all of the world's energy source. The renewables are that tiny little bit at the top. It is true to say that, according to the International Energy Agency's new report, that global investment in energy is now greater for clean energy than it is for fossil fuels, which is obviously a good thing. But to be honest, as long as the investment in fossil fuels is increasing rather than rapidly decreasing, we're not out of the woods. No matter how much clean energy we're producing, if we don't stop or drastically reduce burning fossil fuels, it's really not going to help in the long run. So, having listened to all of that, I really do think that it's time for something completely different.
The earth has warmed 1 degree, that's increased the level of the sea. Warming makes the sea expand.
Oh, sorry. Oh, sorry. Back. Start again. Oh, sorry.
The earth has warmed 1 degree, that's increased the level of the sea. Warming makes the sea expand, it rises up and floods the land. At 2 degrees you can kiss goodbye to Miami and Shanghai. There's 20 million people there, who has that many rooms to spare? By 3 degrees glaciers have gone, with less polar ice to reflect the sun. Refugees will then exceed 250 million. At 1 degree, no surprise, half our coral reefs have died. Such a rich ecosystem, 500 million people depend on them. At 2 degrees, I tell no lie, lots more coral reefs are sure to die. Corals bleach to a ghostly white, it's happening almost overnight. By 3 degrees they will all be dead, gone with the life they supported. They'll never ever grow again, you see, with rising ocean acidity. At 1 degree, land gets hot, though you might think that 1 is not a lot. Extremely hot days per year increase to 4 or 5. At 2 degrees, farmers struggle, food supply is really in a muddle. Extremely hot days per year average 27. By 3 degrees, the weather's gone mad. Food is scarce, things are looking bad. Extremely hot days per year will average 62. We've warmed the earth 1 degree, signs are here for everyone to see. We must make sure we don't hit a major tipping point. There is a risk we can detect of triggering a domino effect. If that occurs, there'll be no way of stopping climate change. If we don't act decisively to combat warming urgently, on our present trajectory, we're heading for 3.2.
The song introduced something that I didn't talk about previously, which I'll just mention briefly, which is tipping points. You're probably familiar with the concept of the tipping point. It's the point at which the situation becomes irretrievable. You basically lose control. And within the climate system, there are about 15 or 16 self-reinforcing feedbacks or positive feedback loops. And these are things that make themselves bad. And make themselves worse on their own. So the worse they get, the worse they're going to get. Scientists, including Professor Tim Lenton at Exeter University, have studied the point in temperature increase when these tipping points are most likely to occur. And the graphic you're looking at now is basically increasing temperature from left to right. So you can see the black line is 0 degrees. So that's a pre-industrial no increase in temperature. And then you've got 1.1, which was the current level of warming. Then you've got the blue band, which is the lower and upper limits of the or targets of the Paris Agreement. And then you've got increasing temperature going up to 8, 10 degrees and off the scale. And for each of the self-reinforcing feedbacks, the pink band is the temperature range within which the tipping point will occur. And the red spot is the point at which it's most likely to occur. So if you look at the top one, for example, the collapse of the Greenland ice sheet, the tipping point there is likely to occur at 1.5 degrees of average temperature increase. And you can see, in fact, there are 4 tipping points that are likely to happen at 1.5. And as we know, there's a 66% chance we're going to reach 1.5 within 7 years and possibly within 4 years. Anyway, moving on, let's have a look at the ecological crisis. This is going to be a much shorter part, you'll be glad to hear. So you've seen this graphic before, and of course what we're concerned with here is the ecosphere, because it's the ecosphere that supplies everything we consume. And within the ecosphere, our population is growing, currently nearly 8 billion people on Earth, but the ecosphere itself is not growing because it's limited by the size of the planet. Now, it's not all of the surface of the planet that is supporting us. It's about 6% of the ocean and 18% of the land that is biologically productive, which is 24% of the total, nearly a quarter of the surface of the Earth, which is 12.3 billion hectares of surface area. And so you can easily whip out your calculator and you can divide 12.3 billion hectares by the number of people on Earth, and you can work out that we've each got an average of 1.6 hectares of the Earth's surface to provide what we need. That's Earth's biocapacity. But because of our numbers, our population size, and our consumption, we don't live within Earth's biocapacity. We're currently consuming, on average, 2.7 hectares worth of surface area. And in fact, here in the UK, because of our relative wealth and consumption, we are each consuming 3.9 hectares worth. That's our ecological footprint. So hence, you have what's called overshoot. You have that date in July where we get to the point of the year when we've already used up a year's worth of the Earth's productivity. And we've still got to get from the end of July through to the end of December. Each year we use about 1.75 Earths worth of resources. And so you might be thinking, well, that doesn't really make any sense. If we're using up the resources of 1.75 planets and we've only got one planet, then, well, that doesn't really add up, does it? Well, it turns out that the way that we're living on Earth now is only a temporary situation. It is unsustainable, and by definition, that means it will end. It's being temporarily propped up, mainly by 3 things. The first of which is we release the energy stored in fossil fuels. If we hadn't done that, there wouldn't be 8 billion people on Earth, bearing in mind that half of the food produced on Earth is produced with nitrogen fertilizers, and nitrogen fertilizer is fossil fuel. It's made from natural gas. Destroying more and more natural habitat as well is sustaining us. So that's not only, destroying the forests, for example, and ocean habitats, but it's also eating wildlife. Think of the amount of fish, which is wildlife that we consume. And we allow our waste to accumulate in our environment, which is a very, very unnatural thing for anything to do. And if you consider the weight of all of our waste, the heaviest part by far is carbon dioxide. So because of these things, these temporary props, particularly because of the destruction of habitats and species, we are now in the 6th mass extinction event that has occurred on Earth. So there were 5 previously. Last one ended 60 million years ago when we lost the dinosaurs. Currently, almost half of the world's bird species are in decline and 13% threatened with extinction. And if you consider all species, it's about 1 million species are currently facing extinction. And according to the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, which is the biodiversity equivalent of the IPCC, the loss of species and habitats poses as much danger to life on Earth as climate change. So in other words, even if climate change wasn't happening, we still have a major problem because of our destruction of habitats and species. What does Sir David say? Wow, okay. Now, armed with this kind of information, a lot of people will get defensive and they say things like, well, we're not the ones currently doing most of the carbon emissions. Go and talk to India, building all those coal-fired power stations, or go and talk to China, also building coal-fired power stations, or go and talk to Brazil. They're the ones chopping down the rainforest. We're not doing it. Why should Britain take the lead? Well, there are some very convincing arguments why Britain should take the lead. So I'm very quickly going to just to explore those. One of them is called BP, and another one is called Shell. They are the second and fourth biggest oil companies in the world, and they're both 40% British owned. Britain has a massive stake in the global fossil fuel industry. And here in the UK, in their wisdom, our government is still subsidizing the fossil fuel industry. And our emissions per person are actually not very much less than somebody in China. And let's face it, we started it. The Industrial Revolution began here in the United Kingdom. And you can see, way back in 1800, we were responsible for nearly all of the carbon emissions that were going on. And as recently as 1900, we were still responsible for a huge chunk of the carbon emissions going on. And other countries learned the Industrial Revolution spread, if you like, from us. It spread from England through the rest of Europe and then into America, etc. And so they followed our example. But we started it. So that means that there's a huge onus on us to actually start sorting it out. There's another reason why Britain should take the lead. Globally, oil companies spend a small fortune every year on trying to stop governments addressing climate change because of the effect it might have on their profits. Well, that's pretty bad, but guess which two oil companies are the very worst offenders? Yes, you guessed it. It's the two companies that are 40% British owned, spending a fortune on lobbying the world's governments to not address climate change or to delay addressing climate change. So there are some really, really compelling reasons why Britain should take the lead. So after that, what we need are solutions. Now, what we're going to do first is look at energy, because energy use is responsible for 2/3 of global emissions, and the production of electricity is responsible for 40% of global emissions. So what are we going to do? Apparently, the most influential thing that we can do here in the UK, in the developed Western world, is to move our money. I don't know if any of you bank with Barclays. Barclays Bank, for example, is the biggest European investor in the fossil fuel industry. Invested £106 billion in the fossil fuel industry since the Paris Agreement. And if you bank with Barclays, that's your money being used to sustain this problem. And of course, it's not just at the personal level. We need to move our money. We need our councils or public bodies to move their money. We need world governments to move their money. We need industry, we need banks to switch their investments away from fossil fuels. We need to switch to 100% renewable energy supplies. So again, that's not just at the personal level. We need governments to do it. We need all our schools to do it. We need all our institutions need to be moving to 100% renewable energy. So we need to get rid of gas and oil boilers, for example, and we need to be wasting less energy. And we need to be generating more renewable energy. My house wasn't suitable for generating electricity with solar photovoltaic panels, so I went for solar water heating, and that halved the amount of oil that I had to buy for domestic hot water and central heating. And since then, I've actually got rid of the oil altogether. Let's have a look at transport. Transport is responsible for 16% of global emissions, and most of that is from short journeys. So what are we going to do? I really do think it's time that we stopped using the most polluting forms of travel. And jet aircraft are by far the most polluting form of travel per person per kilometre. And cruise ships emit about as much as 1 million diesel or petrol cars. So we need to stop buying diesel and petrol as quickly as we can, which means switching to all the alternatives, which I'm sure you've heard of. I couldn't afford to go out and buy a brand new electric car, so I bought a relatively cheap second-hand one from a company quite close to you in Somerset at Shepton Mallet. There's a company called Drive Green, and our car has 100 miles range, which is plenty, more than enough for our motoring, and we charge it up on a normal 13-amp plug at home. It's absolutely brilliant. Okay, let's look at food production now. Food production is the major factor driving the 6th mass extinction event and responsible for 1/4 of global emissions. So what are we going to do? It's an inescapable fact that the only way we can make a significant inroad into food-related emissions is to eat a lot less meat. And if we had a lot less grazing animals, that would free up land for producing a lot more food for people on plant-based diets. That's what we need to do. And we need food that's in season, so we're cutting down on food miles. We need to eat organic, so we're not paying people to kill wildlife. And we need to be growing our own, ideally, and not wasting food. Okay, let's have a look at consumerism. If you put together light industry that produces all our consumables, like the laptop that I'm clicking the button on right now, everything you see around you, that's made by light industry, and then heavy industry producing our infrastructure. If you put that together, it's responsible for about 1/3 of global emissions. And so what are we going to do about that? I really think we need to get out of the habit of buying things that we don't need. We really only should be buying things that we really do need, and nobody needs fashion goods, for example. So if we're going to buy things, why not buy things that have already been used? If you're going to buy something new, buy something ideally that's been made locally or something that can be repaired. My phone was made in Europe, and it comes with a screwdriver. It's called a Fairphone, and it's repairable. I can fix it myself. Reuse, rehome, recycle. Don't waste stuff. Okay, now we're very lucky here in England, in Britain, that we live in a democracy. But do we ever check, after we've had a general election, we've been to the polling station, we've been to the ballot box, we've elected our MP, do we ever check to see what our MP is doing on our behalf? So MPs go to the House of Commons where they vote, and they have various things that they can vote on. For example, they can vote on measures to tackle climate change. And what you're looking at now is a graphic produced by the BBC and the Guardian newspaper showing you how MPs voted on measures to tackle climate change in 16 parliamentary votes in an 11-year period from 2008. If the MP had a strong track record of supporting measures to tackle climate change, they have a dot on the right. And if the MP didn't support measures to tackle climate change, they have a dot on the left. Look at where the Conservatives are. In that 11-year period, and still today, Conservative MPs have a track record of failing to support measures to tackle climate change. It's not a matter of opinion, it's a matter of public record. And that is one of the reasons that we are in the dire situation that we are in. Here's something we can all do. We need to talk about it more. I was chatting before the presentation started with Anna, and we agreed that people just don't talk about it enough, perhaps because we don't feel confident. Well, perhaps now that you've got the information, maybe you do feel like talking about it. We love talking about the weather. Why not talk about extreme weather? We're having it nearly all the time. We just had the warmest start to autumn ever recorded at the beginning of October. We had 2 heat waves, record-breaking heat waves this year. Last year broke records as well, and the year before. The wildlife you don't see anymore. That's a really good starting point because you're hopefully volunteer wildlife surveyors. When did you last hear a nightingale? When did you last see a turtle dove? When did you last come across a curlew nesting on farmland? Your concerns for the future, this presentation, whatever it is, I just think it would be really good if we could all talk about it more than we currently do. Okay, so let's imagine that we did all of the solutions. What we would have, I think, if we did all of those solutions is more time. But that would be really good because more time would mean we'd have more time to adapt to the changes that are coming no matter what we do, and more of that precious time with our families. And if we did all those changes, thinking about growing our food, cycling and walking, we would be in better health and we would have stronger, more resilient communities. And we're really going to need that, particularly when food becomes incredibly expensive. You will be so glad that you got together with your community and started growing more food. The alternative, of course, to doing all of those solutions is to do nothing. And that's all we have to do. We want to see those terrible, terrible outcomes. All we have to do is carry on as normal. So now you know. Now you know what all the fuss is about. We really must act now. And if you do it for any reason, do it for the children. Thank you very, very much for listening. And in the chat, you will notice that I have put the links to a few handouts which you might like to look at. Thank you very much.
Thank you very much, David. That was such a good talk. Hopefully everyone learned so much about so many different things, and hopefully we can all take some of the solutions into our daily lives as well, because some of them are actually so easy to incorporate and you don't need much effort to do them. So we've already had a few comments. So Becky said, honestly, this is one of the best webinars I have attended. I'm on the edge of my seat for more than an hour already. I really appreciate the time and effort you put into this. And Dorothy said, I really hope this will be available later to rewatch and share. And I think it is really important. So we've recorded the webinar so we can send it out to you after. And you can go back through, pick out some of the key stats that you found really important and can share with other people, your families and friends and other volunteers as well. So if anyone has any questions for David, so you can turn your microphone and camera on if you want, or you can type it in the chat and we can get those answered for you.
Can I just firstly say thank you ever so much for those positive feedbacks, the positive comments that you've made. And I really appreciate them because I don't take anything for granted. And I have put a lot of effort into the presentation and I've updated it 24 times since I first created it nearly 4 years ago to keep it bang up to date. And it's also completely free of charge. So if any of you know of a group, any kind of social group, any gathering of people who you think would appreciate that talk or need to have it, perhaps, then do please get in touch. The email address to contact to book a talk, it could be online, is whatalotoffuss@gmail.com.
Perfect. So I don't think there are any questions unless anyone has.
I do have a question. you are so familiar to me. Do you ever hold lectures in University of West of England?
Yes. Not. I don't think they've had this presentation, but in connection
Okay.
with my charity, in connection with my charity work, my wildlife work, I'm pretty sure that we have in the past presented to them, but I don't think they've had this one.
I have another question. On each, there were many tipping points in the carbon emission, which was related to the temperature, and then you could see on the graphs that it was going up and then going down periodically. What was in previous occasions where the temperature started to lower again? And to my understanding, right now we are keeping it up artificially, and that's why it cannot go to that tipping point that, based on that graph, it should already go down in temperature and sea level. So yeah. What caused the change in previous periods?
Yeah, that's a really good question. I think you're referring to the graph with the 450,000 years and the regular increases
yes.
and then decline in the temperature. And that regular pattern actually goes back even further. There's another version of that graph that goes back, I think, 850,000 years. And you can see about 8 or 9 ice ages and warmer interglacial periods. And the reason, the main reason, the most plausible reason behind that is what's called the Milankovitch cycles, which is variations in the orbits of the planets, variation in the shape of the orbits, because orbits are not perfectly circular, and variation in the angles of the axis of the planets as well. And it's actually very complex. But if you want to read about it, if you Google Milankovitch cycles, then you can find out what's behind it. And so I guess if the Milankovitch cycles are still in play, which you would think they would be, then ultimately we would be heading for an ice age. But the science is basically saying that what we are doing now is so fast and so extreme that we have delayed any ice age that is ever coming, will be severely delayed by what we've done.
Thank you.
So we have got a couple more questions as well. So Sarah has asked, I live in a flat. Can you recommend alternative heating possibilities than an air source heat pump, which she doesn't think would be feasible?
Yeah, okay. So whether or not an air source heat pump is feasible depends on whether you've got somewhere to put one. So I think they're normally mounted on the ground. So if you're on an upstairs flat, that might be difficult. And also they're only going to heat a home efficiently if it's well insulated. And if you rent a flat, for example, and the amount of insulation it has is beyond your control, then that would be a major limiting factor. So the obvious alternative to using fossil fuels to heat your home is to use electricity, and you need to use it as sparingly as possible. So you want to go for the most efficient electric heating system that you can afford. And you want to keep the thermostat as low as you can manage so that you're conserving energy, which will help with the cost of it as well. I don't think there's, for somebody in a flat, particularly if they don't own it, I don't think there's any other option. But I'm not an energy specialist. I'm not a home heating specialist, so I would probably take advice from other people as well.
So another similar question, is there a bank you recommend? I searched, but I'm not sure how reliable the articles are.
Yes, okay. So if you want to find articles on reliable recommendations, a really good place to go is a magazine called Ethical Consumer. It's been going for many, many years, and you can look at, I think you pay a subscription, but it's not very much. And you can look at back issues of their magazine articles, and they are so well researched, not only into climate related, emissions related ethics and the best choices to make, but also other aspects like kind of welfare standards for workers and other ethical considerations. So Ethical Consumer is a really good place to go, and they review everything you can imagine: toilet paper, washing machines, cars, energy suppliers, banks, you name it, they reviewed it. So yeah, write that down, Ethical Consumer. So the bank that we use now is called Triodos. It's based in Bristol, so it's local, and you can phone up and speak to real people, which is good. And I know the Co-op Bank is ethical to a very large extent, doesn't invest in fossil fuels. And then there are some building societies. The Nationwide is the one that springs to mind, which is the most ethical, as far as I know, of the building societies. So there's just a few starters for you.
Dorothy's also said that Triodos are great to use, and she's also asked a question saying, any ideas on the best way to overcome the massive media block to discussing this? So much distraction.
Yes, we have a kind of information overload, don't we? And also this is a long-term problem still, or at least for us it's a long-term problem. I suppose for people in the global south who are already starving or abandoning their land because of drought, or being inundated by the sea because they're living very low down to sea level, for them it's already immediate. For us it's still mostly a long-term problem, and human beings are kind of wired up to take more notice of short-term things. And we have, as we said, this kind of information overload. So how do you get around that? Very, very good question. I guess you just have to do everything you can, and you use the tools available. So you use personal contacts, you use social media, and you go out and make people take notice of you. So you maybe go and protest. But these days you've got to do something pretty extreme if you want to get in the media. I mean, I've been on protests in Bristol where there were 10,000 people, and there was not even the local BBC, let alone the national BBC, but the local BBC didn't even mention it. So these days you've got to do something pretty extreme in public in order to get into the media, and that's why people are climbing up buildings and climbing up motorway gantries and gluing themselves to things, is because it's getting harder and harder to get media attention. Just this week, Greta Thunberg was arrested at an oil company meeting in London, and she's in the world of climate activism. She's an international name, but that didn't get in the media at all. So even Greta Thunberg is not news anymore. So it is very, very challenging to steer the media towards the stories that matter. And the other thing, of course, to be aware of is that the majority of the media, particularly thinking of the what traditionally would have been called the newspapers, are owned by very few, very, very rich people who have a different agenda. So we need to make the most of the alternative media that's out there. And of course, the Guardian newspaper is the world leader in terms of reporting the environment.
Oh, so I think that's all the questions, unless anyone else has any. No, I think it was a very comprehensive talk with lots of information to take away and think about. But yeah, so if no one has any more questions, can turn you off and say goodbye. But no, thank you again, David, for the talk, and I'll send out an email tomorrow with the recording link in.
Great. Okay. Thank you ever so much.
Yes, thank you again, everyone, for coming, and thank you, David. Have a good
Okay,
evening.
you
Bye.
too. Bye.